Okay, so since we've taken a look at more derivative rules and we've also learned about higher order derivatives, we're going to take this one step further and actually go into word problems that use real world application. So if you've taken physics, a lot of these terms are going to be very similar. The one thing that's different is that we are going to use calculus to solve the problems. So let's take a look at some of these words. And let's begin with the idea of position. Okay? So the position means I want to know exactly where is my particle, my ball, the rocket, the keys, whatever it may be. I'm asking the location of a certain thing. So typically you're going to get a position function, and this can be called S of t. Sometimes it's seen as x of t, other times it's y of t. And we use all these general terms for different reasons. S of t is just a general term for a position. However, anytime we see an x of t, we know our particle has to be traveling on the x-axis, which is left to right. Whereas if I am on y of t, our object or particle has to be moving up and down. So, let me draw that again, up and down. So, depending on what we're looking at, position can be s, x, or y. Okay. Velocity, on the other hand, deals with the rate of change of position. So I want to know how fast is my position changing, and I also want to know in which direction. And in order to do that, I need to take the derivative of the position. So s prime of t, or x prime of t, or y prime of t, depending on the variable you're using. And finally, the acceleration is the rate of change of velocity, which in this case is the derivative of velocity, which technically is the second derivative of position. So anytime you see one of these problems, it's typically best to write out your position function, take the derivative and label it as your velocity, and then take your derivative again and label it as acceleration. Now, the one thing that you do see every day if you're riding in a car is speed. So a lot of times when we talk about speed, we don't necessarily talk about the direction I'm going. I don't really care if you're going left, right, up or down, but I do care how fast you're going. So when we take a look at speed, I always want the absolute value of velocity. So I'm going to give you a little chart with a few hints as to when to use which equation. Anytime you see the word position, the distance, the height of anything, you're going to want to use these equations right here. Okay, so let me move it down. You'd use either s of t or x of t or y of t depending on the problem. Anytime you see the word maximum or minimum, position, then you should also use the s of t, x of t, or y of t. And most importantly, anytime something is on the ground, is at the ground level, that means you're going to want to set this s of t, or x of t, or y of t equal to 0 to find out when this is actually happening. Anytime you see the words instantaneous velocity, and I'm going to stress this word instantaneous, you want to make sure you use the equation we found for v of t. Anytime it's asking for when something is at rest means I don't have a speed. Imagine a parked car. What's the speed of a parked car? 0. Is it moving left or right? No. So when something is at rest, we say its velocity is 0. There's no change in where it's going. However, I could ask you, is something going up and down, or is something going left or right? And anytime you want to figure that out, if my velocity is greater than 0 or positive, right? So in parentheses, I'll draw a positive sign right here. Anytime I'm positive, that means I'm going up. Just like on the y-axis, positive is up. Or it means I'm going to the right, and just like on the x-axis, that means I'm going to the right. However, if my velocity is negative, then that means my object is going down. And on the x-axis, that means I'm going to the left. That's an arrow, okay? Anytime you see the word instantaneous acceleration, or just acceleration by itself, you're going to use the a of t equation. And anytime you want the speed, I'm going to take the absolute value of the velocity that I found. Okay, so let's take a look at a few more general things, and then we'll start solving these problems. So this says, use the position function s of t equals negative 16t squared plus v naught, this is pronounced v naught right here, t, plus s naught for an object moving vertically near the Earth's surface. So if I am at the Earth's surface and I don't have an equation given to me, I'm going to focus on this position function. It says s of t is measured in feet and t is in terms of seconds. So a few key words to take a look at is initial velocity. And initial velocity means my starting velocity. Was I at rest? Was I thrown up in the air? Was I thrown down? Was I let go? So if we take a look, anytime something is thrown up, so let's say I have 3 balls right here. Here's 1, here's 2, and here's 3. For the first one, if I am thrown up in this direction, that means my initial velocity is positive. Like we said, positive velocity means I'm going upwards. On the other hand, if I am going down, what does my initial velocity have to be? I'm actually thrown down with some force. My initial velocity should be a negative. What do you think is going to happen if somebody's holding this ball and they let go without throwing it down? Well, technically the initial velocity is 0 because there's no force being applied to it. So since I'm on level ground and it's just going to it's going to be dropped, then we're going to say that it has an initial velocity of 0. S naught is our initial height, and this is telling me where we are starting when I'm at t equals 0. If I'm on the ground, my S naught is equal to 0. But in some cases, my object is actually going to be above the ground. So let's take a look at an example to see how that works. It says a baseball is thrown vertically upward with an initial velocity of 46 feet per second by a player who is 6 feet tall. Assume the player releases the ball at his height. So let's actually draw this picture and see what's happening. I have a baseball player, right? So I'm going to draw my baseball player right here. Let's add a baseball cap to him. And it's saying that there is an initial velocity, so let's use the highlighter, an initial velocity of 46 feet per second. It's also saying that this guy is 6 feet tall and he's releasing the ball at his height. So let's draw this out. We know initially I'm going to go upwards. Oops. We know initially I'm going to go upwards with an initial velocity. V naught has to equal 46. Sorry, 46. And then I also know that this guy, he is 6 feet tall. Now, where is the ball gonna start? This says he's releasing the ball at his height. So he's actually throwing the ball when it's right here at his height. So this 6 feet actually represents our S naught because it's telling me at time equals 0 when this first starts, I'm going to be right here, and then I'm going to go up. So let's plug this into the equation we first found, since I need to find the position. And in this case, let us use S of t just to not confuse ourselves. But the general equation from the previous page is S of t equals negative 16 t squared plus v naught t plus s naught. So I'm going to plug in the two pieces of information from our equation, and that gives me S of t is equal to negative 16 t squared plus 46t plus 6. Good. So now I've found the equation for position. The next one is to find the velocity. Well, the definition of velocity is the first derivative of position. So I'm going to take the derivative of this function right here, and that's going to give me negative 32t plus 46. Good. And finally, it says find the acceleration. So the acceleration is the derivative of the velocity, which is then the derivative of this, which is actually equal to negative 32. So that's part A. These equations that we've just found, these three right here, will be used for the next problem. So the next problem says, okay, baseball is thrown vertically. It's the same problem, except now I need to find when this happens when t is equal to 2. So let's use our equations from the previous section. So let's go ahead and do this. I'm going to copy all this. Oops. I'm going to do this. Take this, and take this and this. Let's group it, copy it, and I want to paste it right here. Let's make it a little bit smaller. Okay, so now I have these three equations, and it says determine the height, velocity, speed, and acceleration. Well, when I went over our little chart over here, what did we say I'm supposed to use when I talk about the height? According to this, I'm supposed to use S, X, or Y equation. So I'm going to go back here, and if I'm looking at the height, that means I need to use this equation, S of t, right over here. Oops. So let me just fix my view real quickly. Okay. So if we're doing this, okay, if we are doing this, then I'm going to start to plug in this information. So I'm going to try and type this out. I want S of 2 is equal to negative 16 times 2. Well, 2 squared is 4, so times 4, plus 46 times 2 plus 6. If I continue, this gives me negative 64 plus 92 plus 6. And if we calculate this, we should get an answer of 34. And since this is a word problem, I have to take a look at my units, and my units here are feet. So I'm going to say 34 feet. Okay. So there goes my position. Let's make this a little bit smaller. Okay. Now the next thing says find the velocity. Well, if I'm looking for velocity, which of these equations should I use? I should use my green equation, v of t, and now I'm going to plug in 2. So v of t is equal to negative 32 times 2 plus 46. So if I solve this, I get negative 64 plus 46, and that gives me negative 18. And since it's velocity, as I can see up here, velocity is in feet per second because I care about the position over at a certain time. So I'm going to say feet per second. Good. So let me make this one a little bit smaller just so we have enough room. And move this up. Okay. The next question is asking about speed. Well, we said speed is equal to the absolute value of the velocity. And here I found that the absolute value of, or that the velocity is negative 18. So the absolute value of 18 is 18, and I'm going to say feet per second. Good, so let me shrink this again. Move this up just a little bit. Finally, I want the acceleration. So acceleration at 2 is equal to negative 32. Well, can I plug anything in? No, so I'm going to leave it at negative 32 feet per second, and it's actually squared since I'm looking at how fast my speed or my velocity is changing. Good. Let's do part C. Part C is asking for the average velocity. So we haven't done the average velocity, so let's go back to our chart and add in a new section right here. And so average velocity is taking a look when I have a certain interval of time. So anytime you see the word average velocity, you're going to want to use a specific equation. And so let me bring this down. Actually, let's just do another bar right here. So average velocity is this following equation. Take the position at a certain time, so I'm going to call this time 2. And I'm going to subtract it from, and then I'm going to subtract another time, so t1. And these are typically given to you in brackets, so I'll write that to the side. It's all of this divided by, and I'm going to do this right here, divided by t2 minus t1. Let's just scoot this over. So anytime I'm looking at an average velocity, these have to be given to me. So typically you're going to see t1 in the first bracket, comma, t right here. I'm going to do comma, t. Let's make this a bigger letter, t, lowercase, subscript, t2. So I'm going to start to plug in. Another equation that you're going to see, another equation that you're going to see here is the average acceleration. And so average acceleration is a phrase that you just might see, and you're going to use a slightly different equation. However, I still need to have a T1 and a T2. So let's move this down here. And what you're going to see is I'm going to take the same equation, but since acceleration depends on velocity, I'm going to change these S's into V's. So we're going to use these two new equations to solve the rest of these pieces. So let me delete these. Okay, so let's go back to our problem. And it was talking about the average velocity. So what I'm going to do is I'm going to copy this equation and see how it's used. So it says, what's the average velocity of the baseball over the first 2 seconds? Well, now I have to take a look at the time. What exactly does this mean? The first 2 seconds means where am I starting? Good. So I hope you said that means I'm starting at 0. Where am I ending? At 2. So I need to plug in 0 and 2 into these equations. So let's do that. I'm going to get s of 2 minus s of 0 over 2 minus 0. And that's because, like we said earlier, this right here is your T1. This right here is your T2. Now you might ask, okay, I know how to do the denominator, but where do I get these s's from? Well, where is the s equation that you had before? Exactly, it's right over here. So I'm going to copy and paste this again. So now what I'm going to do is I'm going to plug in to this s of t equation that we have, and I'm going to put it right here so we can still see it. So what I'm going to do first is, let me move this over, just so we have some room. So I'm going to find s of 2, which we found earlier. S of 2 is equal to 34 feet. So on here, I'm going to say is equal to, what did we say it was? 34? Yeah, so we said it was 34 feet minus, I have to plug in 0, so s of 0 is equal to negative 16 times 0 plus 46 times 0 plus 6. So if I take a look at this work, I'm going to notice that this cancels, and s of 0 is actually equal to 6. So I'm going to plug that in right here and say 6 feet. Let me underline that to show it's a division problem. And if I move down, 2 minus 0 is 2. And if I look at my time, it's seconds. So if I do my math up here, I'm going to get 34 minus 6, which is equal to 28. I have 28 feet divided by 2 seconds. So if I scroll down, I'm going to just say 2s just for to make it easier. And that's good. Oops. And that's going to give us an answer of 14 feet per second. Let me just extend this. 14 feet per second. This right here is our answer. Good. The last question says, what is the velocity of the ball the instant before it hits the ground? So we need to take a look at what I'm looking for. So according to this, it says, what is the velocity? So I'm looking for velocity, and I know the equation for just velocity, not an average velocity, but just velocity, is v of t. Then it says, well, I want to know when this is happening, when it hits the ground. When I hit the ground, is that telling me about the position, the velocity, or the acceleration? Well, what it's actually telling me is when my position is equal to 0. So let's type this instead. And I'm going to say the position is equal to 0. Well, in this case, position is the same as s of t. So what I'm going to do is set s of t equal to 0. So according to our equation from before, s of t is up here. So let me copy and paste that again. And so what I'm going to do is say S of t is equal to negative 16 t squared. So let me get my square. Okay, sorry. T squared plus, plus 46t plus 6. I want to set this equal to 0. So the only way to do this is to actually factor this out. And I'm going to pull out a 2. And once I pull out a 2, I'm going to pull out a negative 2. When I pull out a negative 2, I'm going to get 8t squared. T squared. T squared, and instead of a plus, I get a negative 30. We're going to get a negative 32t. Oh, sorry, not 32. Negative 23t plus, minus 3. Set that equal to 0. If we do some factoring, we're going to get negative 2 times 8t plus 1 times t minus 3 to get us our different variables. I'm going to set this equal to 0. If I take a look at that, that means I'm going to take 8t plus 1, make that equal to 0, and do t minus 3, make that equal to 0. And if I solve, I'm going to get 8t equals negative 1 on this side, and I'm going to get t is equal to negative 1 divided by 8. Well, can time be negative? No. So this time actually doesn't count for us since it's a negative time. So I'm going to continue to solve this part right here. So let's do that on this side over here. If I solve for t, what I actually get is t is equal to 3 seconds. Well, is that a time that would possibly work for us? Yes. So now I have to check if I've answered my question. My question is asking about velocity. Well, did I find the velocity? No, but can I find the velocity? Yes, because if I look at v of t, I have the equation for v of t right here. The only thing I need to plug in is a t. Do I now have a t to plug in? Yes, so if I do this, I get v of 3 is equal to negative 32 times 3 plus 46, and that gives me negative 96 plus 46, which gives me negative 50 feet per second. So at t equals 3 seconds, my particle is moving 50 feet per second, and since it's negative, I'm going down. Good, so let's take a look at a couple problems in a minute. Go ahead and take a break and just go over your notes for a little bit. Thank you.